Okay, so now let's talk about the graph of sine and the cosine function. Okay, sine and cosine function. So for this kind of question, we have three important definitions. Okay. So first one is the amplitude, which is the absolute value of a, and then we have period of the function. So this is 2 pi over b, and then the last one is called phase shift, or you can also call this starting point of the pattern. Right, so this is 0 of the trig function. Of the input of trig function. Okay, so we have these three important definitions. Okay, three important definitions. So now let's look at the first example. So let's understand the three calculations first. So what's ABC, right? What's ABC? So first example, y is 2 sine x minus pi. Okay, so the regular form is y is a sine bx plus c, or minus c, right? Or minus c. So here a is for the amplitude. So for this example, a is 2, right? A is 2. And then b is how many x you'll have, right? Multiplier of letter x, the angle x. Okay, so b is 1 for this example. And then for the phase shift or starting point, we need 0 of the input of trig function. The trig function is sine, so this is the input, right? Input. So the last one we need bx plus c is 0. So in this example, is pi minus x minus pi is 0. Okay, x minus pi is 0. So this is the understanding of these three definitions. Okay, three definitions. Okay, so later I will calculate and then do the graph. Okay, do the graph. So now let's look at the second example. So second example is y is negative 3 cosine 2x plus pi over 3, right? Pi over 3. So now a is negative 3 here, right? And b is 2. Okay, yeah. And then 0 is for this whole input, right? Input. So this is 2x plus pi over 3 is 0. Okay, yeah. So that's how we find the starting point. Okay, that's how we find the starting point. Okay, yeah. So now let's do these two graphs separately. Okay, let's do these two graphs separately. So go back to number 1. Y is 2 sine x minus pi. So a is 2, b is 1, right? B is 1. So first you give me a and b. So now we know amplitude is absolute value of a. So this is absolute value of 2, 2, right? And then period of the picture. So this is 2 pi over b. So this is 2 pi over 1 is 2 pi, right? Is 2 pi. And then the last question is phase shift, or the starting point of the curve. So this is x minus pi. This whole thing, the input of sine function equals 0, right? Equals 0. Okay, so x minus pi equals 0. So plus pi, you got x is pi. Okay, x is pi. So that's the three information that we need to draw a picture. Okay, to draw a picture. So now what's the sine curve? Sine curve is start from 0, go up to 1, go back to negative 1, go down to negative 1, go back to 0. Go back to 0. So this is the starting point of phase shift. So let's use a green color. Okay, this is the starting point of pattern, right? And then what's the end point? The end point will be the phase shift plus the period. Okay, so how long we traveled here on the x-axis, this is the period. Okay, this is period. Okay, so now let's draw this picture. So it's sine curve. We know the pattern is up there, and then this curve starting at pi. So this is pi. The pattern starting at pi. So we draw the pattern, and then label it. Right, label it. So starting point is pi, and then the end point is pi plus the period 2 pi. Okay, so you don't have to simplify to show me 3 pi. Okay, to show me 3 pi. Okay, let's still use the green color. So this is how long the period, how big the pattern is, right? It's 2 pi. Okay, 2 pi. And then what's amplitude? Amplitude is the height. Right? Amplitude is height of the curve. So the curve is bounds between 2 and -2. Okay, 2 and -2. So this is the key pattern of the sine curve. And then you just extend it, repeat this pattern to the left, to the right. Then you got whole sine curve. Okay, whole sine curve. Okay, so that's the first example. So if A is negative, there will be a reflection. So we will do that part in the second example. Okay, second example. Okay, so you have to remember the pattern of the sine curve, and the phase shift starting point is the 0 of the input of the function, and then the end point is phase shift plus the period. Okay, so now let's look at number 2. So number 2 is y is -3 cosine 2x plus pi over 3. Okay, so here A is -3, B is 2, right? B is 2. C is not important. You don't have to write down C is pi over 3, okay? Yeah. So that this negative sign means we have to reflect the whole curve in the end. Okay, in the end. So first we draw the curve for A is 3, and then we reflect it to get the curve A is -3. Okay, A is -3. Okay, so now let's first find amplitude. That's the absolute of A, so it's absolute of 3, so this is 3. So that means the curve bounds between 3 and -3, right? And period is 2 pi over B. This is 2 pi over 2, which is pi, right? Which is pi. Okay, yeah. And then we have to find the phase shift, or the starting point of the key pattern. So this will be the input equals 0. Input of cosine equal to 0, right? 2x plus pi over 3 is 0. So now minus pi over 3, minus pi over 3. We got 2x is negative pi over 3. So divided by 2, we got x is negative pi over 6. Okay, x is negative pi over 6. Okay, so now we know the curve will start from here, right? So now what kind of curve? What kind of pattern, right? So for cosine is different. Cosine, it will start from 1, go down to -1, and then go back to 1. So it's like a curly V, right? It's like a curly V. Okay, so that's the cosine pattern. Okay, cosine pattern. And then this will be the x-axis, right? X-axis. So here will be the starting point of phase shift. At this point, and then how long we travel, that's the period rate. So the end point will be again the phase shift or starting point plus the period. Okay, plus the period. So now let's look at this particular example. So first we start at negative pi over 6. So this is negative pi over 6. And then we traveled a pi. Okay, so this is pi, right? This is negative pi over 6 plus pi, right? So this is 5 pi over 6. If you like, you can do that, simplify that, okay? And then we draw the pattern. So this pattern is from the top 1, go to -1, and then go back to the top 1, okay? And it's symmetric, okay? And it's symmetric, okay? Yeah. So now where is the y-axis? So y-axis is somewhere here, right? Okay, somewhere here. So by y-axis is not important. By y-axis is not important. Okay, yeah, so now let's repeat it. To the left, to the right, then we got the whole curve. Okay, and then the amplitude is 3, so this is 3, and this is -3. Okay, so the upper bound, the lower bound of the height of the curve. Okay, on pattern curve. But this is for a equals 3, right? So this is the curve y is 3 cosine 2x plus pi over 3. Okay, we got this curve. Okay, we got this curve. But here we got negative sign here. Okay, the given function is negative. Okay, a is negative, so we have to reflect. So now let's change to green color. You reflect the whole curve, right? Reflect whole curve. So this one reflect you from the bottom, so you'll get a curly end, something like, right? That's the reflection, right? Reflection. So now let's draw the reflected curve, and then continue, right? And continue. This way to the right, and then this way to the left. Okay, to the left. Okay, yeah. So you draw the positive 3, the graph, and then you reflect it. You got the graph for negative 3. Okay, negative 3. Okay, yeah. So now similar, sine and cosine curve are very similar. So the only difference is the pattern. Okay, the pattern. So let me repeat the pattern here. So for the sine theta or sine x, this is the pattern: go up, go down, and then go back, right? It's like a horizontal S, right? And for cosine, so this is like a curly V. Okay, from the top, go down, and then go back to the top. Okay, go back to the top. So that's the graph part. Okay, graph part. You have to show me these 3 numbers and then draw the graph, right? Starting point, phase shift, period, and amplitude. Okay, so now let's talk about the identity. Okay, identity. So we will only verify identity, which means left hand side is equal to right hand side. Okay, so you have to simplify both sides to show me they are exactly the same. Okay, they are exactly the same. Okay, so in our review list, there are 4 questions. So now let's write down the step 1 and the step 2 for the trig identity. Okay, trig identity. So what's step 1? Step 1, we change everybody to sine, cosine. Okay, yeah, so we got, if you got cosecant, that's 1 over sine. If you got secant, that's 1 over cosine, right? Yeah. And if you have tangent, so this is sine over cosine. And if you got cotangent, this is cosine over sine. Okay, so we are using this right triangle to remember the property. This is sine theta, r is 1. This is cosine theta, that's the angle theta, right? Yeah. So you look at tangent. Tangent is opposite over adjacent. So you got sine over cosine for the angle theta. And cotangent is adjacent over opposite. So you got cosine over sine. Okay, cosine over sine. Okay, so that's step 1. And then you try to get only 2 functions, sine, cosine. And then we change them to 1 function, right? Sine theta squared plus cosine theta squared is 1. So that's the Pythagorean theorem for this triangle. Okay, another form, you can move 1 or move squares to the right hand side, then you got equivalent theorem, right? Sine squared can be replaced by 1 minus cosine squared, and cosine squared is 1 minus sine squared. Okay, sine squared. Okay, yeah, so if there's a second power, you can think about whether do we need step 2 to see the left hand side is equal to the right hand side. Okay, so now let's look at these 4 examples. So number 1, we want to verify secant x times sine x plus cosine x is 1 plus tangent x. Okay, tangent x. Okay, so now what's left hand side? Left hand side, first we change secant to 1 over cosine x, right? And then we got sine x plus cosine x. So this is sine x plus cosine x over cosine x. So this is left hand side. Okay, left hand side. So now right hand side of the equation, we got 1 plus tangent. So tangent is sine x over cosine x. Okay, cosine x. So now if you change to common denominator, change this to cosine x over cosine x. That's number 1. then we got exactly the same expression, right? So common denominator cosine, then we got cosine x plus sine x. Okay, so a lot of questions in this part you need common denominator. Okay, you need common denominator. So now you see the left hand side and the right hand side are exactly the same, right? That means we verified, we checked the identity. They are equal, right? They are equal. So that's number one. Okay, so number two, we want to show cotangent x is cosecant x over secant x, right? So now what's left hand side? Left hand side is cotangent. Cotangent is cosine x over sine x. Okay, so if you forgot, you can draw this triangle again, right? 1 sine theta cosine theta. Okay, yeah. And then for the right hand side, we have, so let's change this bar to divide. Okay, to divide. So we have cosecant. Cosecant is 1 over sine, and then secant is 1 over cosine, right? So now we have to flip and multiply. So this will be cosine x over sine x, right? So now they are exactly the same, right? They are exactly the same. So left hand side is equal to right hand side. We got the identity. Okay. If left hand side is not equal to right hand side, that's called disprove the identity. The identity is wrong, right? The identity is wrong. Okay. Yeah. So that's the two easy examples that you only need step 1, right? You don't need step 2. Okay. You don't need sine squared plus cosine squared is 1. Okay, so now let's look at number 3. So we want to show sine x times tangent x plus cosine x is secant x. Okay, secant x. So now this one, the left hand side, so again change to sine cosine, right? So this is sine x over cosine x. That's for tangent, right? That's for tangent. Plus cosine x. So we got sine x squared over cosine x plus cosine x. Okay, so if you use common denominator method, change this to cosine x over cosine x, then you get sine squared plus cosine squared over cosine x. So this is 1 over cosine x. Okay, so now what's the right hand side? Right hand side is secant. So secant is 1 over cosine. So we got left hand side is equal to right hand side. Okay, right hand side. So we use common denominator again. Okay, common denominator again. But if you didn't realize, you can use common denominator. So you can change the number 1 in the right hand side to check the identity, right? So there's a number 1. So what's 1? 1 is sine squared plus cosine squared, right? Cosine squared. So now we change it to sine squared plus cosine squared for the right hand side over cosine. So now we got sine squared over cosine plus cosine squared over cosine. So now cosine squared over cosine is cosine. So you still got left hand side equals right hand side. Okay? Yeah, so you change this number 1 on the right hand side, you also get the identity. Okay, so change 1 to the square, sine squared plus cosine squared using the Pythagorean identity. That's one way. Common denominator, and then use this Pythagorean identity. That's another way. Okay, that's another way. So anyway, we need to see left hand side is equal to right hand side. So the last example, we want to verify cosecant squared is 1 plus cotangent squared. Right? So what's cosecant? 1 over sine. So this is 1 over sine x squared. So it's 1 squared over sine squared. So it's 1 over sine squared. That's left hand side. Right hand side is 1 plus cotangent squared. Cotangent is cosine x over sine x. Right? And then squared. So this is 1 plus cosine x squared over sine x squared. Okay, so now it's the same situation. Okay, same situation. You can change this to sine squared over sine squared. Common denominator, right? That's how we add or combine fractions. Then we got sine squared, and then sine squared plus cosine squared. So this is 1 over sine squared. So you see the left hand side and right hand side are equal, right? Using Pythagorean identity. Okay, Pythagorean identity. So again, you can also change the 1 on the left hand side like the previous example, right? You can change it to sine squared plus cosine squared. Change the 1 to this divided by sine squared. Okay, so now this will give you 1, the number 1, and the other side, this side give you cosine squared plus sine squared. And you still get left hand side is equal to right hand side. Okay? Yeah. So 1 is a very important number in this kind of step 2 of verify identity. Okay? Identity. First you change everybody to sine cosine, and then try to use squares, sine squares plus cosine squared equal to 1 to check the identity.